So our next speaker is Ignas Bagdonas from Equinix, our main sponsor, actually. And he's going to talk about feeding interconnection and growth, Stockholm Metro. So, welcome.
Thank you, and good morning. I'm Ignas, and I had to change my name from Martin Atkinson, as you might have seen on the agenda previously. So Martin is peering manager from Equinix who was not able to be here. So I had this opportunity to run through the marketing content, and at the same time, this is a beautiful opportunity to add in some hardcore technical things, to wake up the audience from mails and sleep. So let's start. There are three topics here to discuss: an overview of Equinix products, and overall marketing view specific to the region here in Nordics, and then a couple of technical topics to look at the developments of trying to insert the services or defining the service interface into the internet exchanges. And a brief update on the topic that I have been speaking here in the spring meeting about the new developments in Bgp, and especially the Bgp communities. So very briefly, Equinix is a large interconnectivity operator present around the world with many locations, including Nordics here, which comes via acquisition from Telecity, and that's in the process of being integrated into the full Equinix product portfolio and operations. What Equinix does, it provides a set of products for end-to-end connectivity. It's not only an exchange, it's not only the colocation facility, it's not only the local intermetro interconnects, it's everything from end-to-end. Taking these components and combining them together, you get the connectivity that can be customized and tailored for your particular needs. If we briefly look at the history of 20 years of interconnection in one slide, that's how it looks like, starting from the need for interconnect of the actual networks, the, say, separate networks, then the content coming in, then the content consumers in the terms of commercial organizations coming in, and eventually growing into the large interconnectivity of specific cloud providers, specific cloud consumers, local content providers, content users, and other players in the market. There are different types of interconnect services, and there are different types of requirements for those interconnect services. One is for the internet exchange type of products, where only the peering parties exchange local traffic. Cloud connectivity is another one, where you can have customized connectivity into the cloud providers locally, where that cloud provider is present, and have multiple connections in different regions, depending on your actual requirements. If we're looking into the perspective of that, one trend is very clear that is growing. So more locations, more speeds and feeds, faster rates, and more interconnected elements. And in order to eventually manage and practically use of this, you need technical components which sit below, which are not necessarily visible from the outside, that would eventually enable this. And Equinix, as an operator, is very much interested and open collaborating with the community on the standardization and technology development perspective of trying to bring in into the industry solutions and approaches which could be interoperable and interworking with other players in the industry, trying to address the shortcomings both of the technology and the architectures that are present at this point point of time, and trying to develop the approaches which eventually help solve the actual connectivity problems. If we are looking overall end-to-end, Equinix as an organization, as an entity, is one node in the whole in this whole interconnection picture. So, marketing aside, let's move to more interesting topics, so to say. Services in the exchange. So for quite a while, Internet Exchange has been seen as a separate, standalone, and untouchable platform. It is doing its function, which is rather basic, providing connectivity from point A to point B, and that's it. The rest of the services are in the realm of the actual peers, the members of that exchange. And visibility into the operation of exchange typically is, I cannot say non-existent. Something is present, but that is not necessarily available outside of the IX operator. And that is not necessarily available up to the level which would be able to help in quantifying the services delivered over that exchange. If we're looking at the overall development trends, Internet Exchange is no longer one single node in one single location. Typically, it's a multitude of them. It's a fabric. It's a rather complex and richly interconnected topology, which needs to be maintained, which needs to be operated, and you would better have some visibility into what is happening there and also some control into that. The common approach to this today that we have a route server which is considered to be a control plane of an Internet Exchange, and it provides some control and some visibility into the routing. But the actual data plane fabric operations are not visible, and an ability to control the data plane operations is non-existent in a standardized and a uniform way. So if we try to categorize the services of the IX, three large groups could be seen. One is the actual fabric operations. So those are the functions which define and control how the actual IX interconnect platform works. Then there's an interface between the peer and the IX platform. So ability to signal and to have the visibility into the interconnect links into the IX fabric and between a pair of between two particular pairs. And then on top of that, the third group would be the services which could be run on top of the exchange. I would tend to call them over-the-top services or value-add services, something like ability to measure and quantify the properties of the fabric, ability to control and have visibility into the paths taken, signal something into the X fabric, for example, denial of service protection and other options. So let's look into each of these groups in a little bit more of a detail. Fabric operations. There are multiple, typically parallel links among the set of nodes which implement the fabric. Ability to see which particular link is being taken is definitely needed. Ability to influence by injecting a certain level of entropy and controlling which paths could be taken seems to be also needed. Ability to pin certain flows for certain traffic classes to particular paths and do some other topology control appears to be needed. Again, it depends on how particular exchange can be architected. But if we are talking about a generic wide tree, there's an ability to segregate critical and less so critical infrastructure connectivity over the same fabric just on a logical level. If we are talking about the peers connectivity, The main function which is required is to reliably detect the failures or impairments into the fabric operation from a perspective of the two interconnected pairs. There's no control, typically there's no control plane connectivity between the parties involved in the traffic exchange. Today you have a BGP signaling session with the route server, but the route server is out of the data path. It's not within, and if you have a failure within a data path in the fabric itself, that's not necessarily easily detectable. A mechanism which would allow to dynamically signal and establish data plane liveness based on the actual topology of the flow seems to be needed. So if you advertise a prefix to a route server and some other peer accepts that and uses that as a best, those two pairs could agree and establish a data plane liveness mechanism, for example, BFD or layer-specific OAM mechanism, only between those two pairs. The brute force possibility is to run data plane validation among any and all of the pairs in the fabric, but that is definitely not practical and not scalable. The services which could be run over the top of the exchange typically include the SLA validation. The end-to-end propagation delays reachability to a particular next hop, which actual path was taken, the recording of the paths traversed, ability to influence which paths could be used, time stamping both on the data plane and the control plane, ability to inject the peer-controlled OAM signaling and to validate that on the other side, and services like that. Overall, this could be termed in a broad group of OAM functions, which would allow a visibility into the operations both of the IX fabric and the interconnect into X fabric, and on top of that, possibly using additional services. The first use case for such additional services seems to be denial of service protection. Today, there are mechanisms for signaling black holing communities, which is again is a BGP signaling based. However, we can argue that community-based black holing helps to complete the denial of service and not necessarily mitigates it. It's an all-or-nothing solution, and if you signal the black hole community for a particular destination, that destination eventually becomes unreachable, instead of having a much more granular type of filtering, which, again, as an example, BGP flow spec could allow. This, of course, opens a broad topic of regulatory and legal questions, whether the exchange is allowed to touch and at least inspect the traffic which is flowing across it, even more whether it is allowed to interfere with that traffic. It's definitely not a finalized solution at this point of time. This is more of a call for discussion with the community, whether this is seen as needed and how this could be progressed further. So trying to summarize that, the important part of trying to add the additional services into IX is that IX still needs to continue operating. So its stability should not be compromised within the practical limits. One of the first use cases for value-added services, well, actually two cases for value-added services, is the denial of service protection via means of flow spec or equivalent mechanisms, which can inject the granular filters, and the end-to-end data plane liveness control and detection. On top of that, ability to validate and measure the actual connectivity service level agreements is another one. So moving to another topic, BGP and developments in the particular topic of large communities. The problem space is very simple. 4-byte AS numbers today are deployed. There are no more 2-byte AS numbers left. and they are used. Routing policy, on the other hand, has no practical mechanism to express the routing policy in terms of 4-byte AS numbers. There are various hacks or semi-solutions of trying to address that, but there is no clean 4-byte AS unambiguous solution until today. Overall, there seems to be an agreement reached within the operators and vendors at ATF to try to progress one of the possible solutions at a rather rapid way and get the actual deployment experience. So stepping a little bit back, first the problem space. The standard communities, they have been here for over 2 decades, and they are universally accepted and universally used. However, they simply lack space for expressing the policy in terms of 4-byte AS numbers. They were defined for 2-byte AS numbers. Extended communities, which were originally developed for different reasons, for VPN address families, they have a semi-solution for that. Basically, extended community defines a container which is capable of carrying 6 bytes. That's a little bit better than 4 bytes with a standard community, but that is still not enough to carry full policy of AS4:AS4. If we look at the practical deployments today, yes, extended communities are being used for plain IPv4 and IPv6 address families just for this same purpose, for signaling the 4-byte AS numbers policy. IPv6-based extended communities, they are specified, however, there are no practical implementations of that, and while theoretically could be possible to use that, it's undeployable. There is a specification which is called 4-byte 4-octet extended communities. However, the only thing that it does, it redefines the value of certain fields. It's still that same 6 bytes container, and you cannot put 8 bytes of required information there. There is an alternative proposal, wide communities, which has been in specification stages for a while. However, there are no practical implementations, at least at this point of time, for a very simple reason. The proposal itself is quite complex, both from implementation point of view and from the operation point of view. It potentially changes the routing policy constructs needed to express your intent. Therefore, a few of the operators got together and started thinking about the actual requirements, and the result of that is a proposal called Large Bgp Communities, which is today a working group draft accepted by the IDR working group, which is progressing rather rapidly, and optimistically we might see this shipping from vendors starting from next year. Large communities has a very simple concept which continues along the standard communities. No fields, no extensibility, no TLVs, simple as possible, just allow for carrying more space for information. Large communities on purpose move away from treating the fields as AS numbers. This is just a 32-bit integer, and it's up to your policy to interpret that as an autonomous system number or something else, an identifier which is local to your network. Similar to standard communities, there are 2 parts, the local and global, and one addition is that there are 2 local parts. So basically you have 64 bits which you can interpret freely within your network. The overall concept is that it's a triplet in the form of my AS, your AS, and value. And you create your policy based on these fields. There are no well-known community values. There are no reserved. There are reserved values for normal ATF requirements to have the protocol extensibility. There are no well-known community values. For that, you still need to use standard communities. Large communities does not obsolete any other community types. Large community is not a competition to wide communities. They solve different problems. Large communities is a practical way forward of having working and reasonably simple mechanism which can be deployed and operated quickly. So the current status of this, that there are, if I'm not mistaken, 4 open source implementations, and a few commercial vendors have committed of having this available in their products early next year. The specification seems to be rather stable, and it's mostly the wordsmithing going on. And what is needed now is explaining to the community how this mechanism could be used, how it could work, and how you could use that in expressing of your routing policy. So basically, it's a simple and elegant extension to a very practical problem of expressing the policy within the context of 4-byte AS numbers. With that, that's it from my side. And I would be very much interested in feedback and discussions either now or afterwards, over the break or the social, about the 4-byte AS for large communities and the IX services constructs. If you would have any questions now or later, I'm happy to talk about that. Well, if not, then I'll leave you back to your emails.